Good morning, boys and girls. For those of you who don't know me, my name is Mrs. Pingle, and at Pritchett School, I will be doing all different kinds of technology projects with you and STEM projects. So most of you I know from being your teacher at Pritchett in past years, but for anybody who's new to Pritchett, it's so nice to meet you, and I can't wait to be back at school with you in person soon. So here we go. It's our first project for third grade. We are going to start with our first project it's the same project that I would be doing with you if we were at school. We are going to be doing some different projects, building STEM towers. This is a STEM tower challenge. So if we were at school, it'd be a little bit different because I would have all the materials there for you to use. Because you're at home, I can't provide the materials for you, but we will talk about how you can do this STEM challenge with whatever you have at your house. So for those of you that were at Pritchett in second grade last year, some of you had the opportunity to do something with me called Project Lead the Way. Not every class had the chance to do it before we had to stop doing school in person and start doing e-learning. So not everybody had the chance to do Project Lead the Way, but through Project Lead the Way, we learned something called the engineering design process. And we are going to review the engineering design process. Even if you did Project Lead the Way in second grade, there's a good chance that you don't remember the engineering design process, and some of you have maybe never heard of that before. So we're going to learn the engineering design process today, and whenever we do a STEM challenge or a STEM project, I would like us to be following that engineering design process. So we're going to start by watching a video that will talk about the engineering design process. And then we will go over how we're going to use that for our first STEM challenge, which will be building the towers.
I'm gonna take a wild guess and say you've probably used the phone. And I bet you've enjoyed the benefits of a little thing we call air conditioning. You know who made those things possible? Engineers. We were just talking about engineers in our last video, people who design and build things to solve problems, and there are lots of different kinds of engineers. No matter what type of engineer you want to be though, civil, mechanical, electrical, or a kind that doesn't even exist yet, there's a series of steps that all engineers follow when they're trying to solve a problem. This process is called, wait for it, the engineering process. Makes sense to me. So what sort of steps are included in the engineering process, and why do we need it? Let's go through it step by step and discover how awesome things are made. First thing you gotta do is just define the problem. I mean, before you can solve a problem, you have to figure out what it is, right? For example, back in the 1800s, an engineer named Alexander Graham Bell was trying to come up with a simpler, cheaper way for people to communicate. Back then, the best you could do was a telegraph, which was an old-fashioned system of sending messages over electrical wires. Bell identified his problem. Communicating with people who were far away was expensive and took a lot of time. So his invention or solution to this problem was something you may have heard of: the telephone. Nice. Now, once you've figured out what problem you want to tackle, you need to do your research. You can start by just making a list of questions you have and what information you need to start answering them. You can also look around and find what other things already exist that have tried to solve the same problem. Maybe they can be improved. A good example here is the man who helped us blow stuff up. The chemist and engineer Alfred Nobel invented the explosive known as dynamite, not because he particularly enjoyed explosions, but because miners and other people who, well, needed to blow stuff up to do their jobs needed an explosive that was safer to use. So before he started on that problem, Nobel did research to see what explosives already existed, which ones worked well and which ones didn't. This takes us to step 3. Develop a solution. After your research is done, this is where you say exactly how you think you can solve the problem. And once you've thought of a good solution, you have to figure out how it'll actually work and what it will look like. So you have to design your solution. This is where you get to draw. Civil engineers always sketch out their ideas, like buildings and bridges and towers, to show what they'll look like when they're done. Gustave Eiffel designed the famous Eiffel Tower in France, and he definitely showed up on day 1 of construction knowing exactly what it was gonna look like. like. On to step 5, build a prototype. A prototype is just a simple model that lets you test out your design. It can be as big as the real thing's going to be, or it can be a smaller version. You just need to have a prototype so you can test it. This may be the most important step in the whole process. Engineers need to test their design to see if it works like they want it to. So, say if your building's a big tower, does it stand up? Does it stay standing up? If you're designing something with moving parts, does it work the way you want? Now take it from me, my future engineers. You might have a great idea, a really terrific solution to a really big problem. But when you get to this step, your prototype probably won't work exactly the way you want. At least, not on the first try. Most engineers test their prototypes over and over and over again. That's why a lot of time and brain power goes into the very last step: evaluating your solutions. Evaluating just means asking yourself whether things are working the way you want, or why they are, or aren't. I like to think of this step as question everything. This is when engineers review all of the facts and ask themselves questions, followed by even more questions. What worked well? Why did it work? Why didn't it work? How could it be made better? And most of the time, the answers to these questions are going to send you back several steps. Like, once you figured out why your prototype wasn't working, you'll have to design a new solution and then build it and then test it again. Sometimes engineers go through this process 4, 5, even 6 times or more. Take Willis Carrier, the inventor of modern air conditioning. He tested his prototypes for years before he figured out the design that worked the way he wanted and solved the problem he wanted to fix. Like all engineers, he failed a lot before he succeeded. And that's okay, because he learned something from every failure, which made his product even better in the end. And I, for one, am glad he kept going. So the engineering process is a series of steps that engineers, or anyone, should use when they're facing a challenge. The process is important because it allows engineers to experiment and also to fail. Both of these things give engineers a chance to go back and improve on their original idea, giving us something even better down the road. So the next time you fail at something, don't feel too bad. Think about the telephone and the air conditioner and the Eiffel Tower, and then try again.
Okay, are you ready to start your STEM challenge? So, what was the first step that Sabrina talked about in the video of the engineering design process? Did you hear what the first step was? The ask step. So the first thing we have to do is make sure we can identify what the problem is that we are trying to solve. Okay, here is the problem that you are trying to solve. You will need to build the tallest tower that you can using materials that you can find around your house. You are going to be doing this each day for 4 days. So you're going to need to be building 4 different towers. What is the tallest tower that you can build using materials you can find around your house? Before we start working on building our towers, we're going to take a look at some of the other tallest towers in the world and see if that can help us as we start thinking and planning for building our own towers. We're going to take a look at the top 10 tallest buildings, skyscrapers in the world, and we'll see if we can figure out what architects and engineers had to think about as they were designing these skyscrapers. So let's take a look at these different buildings. So the tallest building in the world is called the Burj Khalifa, and I'm actually not going to talk a lot as I go through these different pictures. I'm just going to let you take a look at them. As you look at the pictures of these skyscrapers, I want you to really look and see, what do you think the engineers did and the architects as they were planning and designing these buildings? What did they have to think about in order to make sure that these buildings were safe but also tall? So this is the first skyscraper. The tallest in the world is the Burj Khalifa in Dubai. The next one, this is the Shanghai Tower in China. Next, we have the Makkah Royal Clock Tower in Saudi Arabia. This is the Ping An Finance Center in Shenzhen. This is the Lotte World Tower in Seoul, Korea. Next, we have One World Trade Center. This is in New York City in the United States. This is Guangzhou CTF Financial Center in China. Next is China Jun in Beijing. Next, we have Taipei 101 in Taipei. And number 10 is Shanghai World Financial Center in Shanghai. So as you looked through those pictures, what did you notice? When architects and engineers are planning tall skyscrapers and tall towers, what do you think they have to think about in order to make sure they are tall but safe? So I want you to think about these two words, structure and stability. Do you know what stability means? Stability means that it's stable and solid. So if there's a strong storm or a lot of wind, we wouldn't want that building to fall over, right? That would be really unsafe and dangerous. So when engineers and architects are planning these buildings, they need to think about that. What will be able to make this structure tall, but yet still be able to withhold and stand up to strong winds and storms and other kinds of things out in the outdoors? So what do you think they have to think about as they are planning these buildings? So one thing they have to think about is starting with a strong foundation. So the foundation is the base, the bottom of the building. If you don't have a strong foundation, you're not going to be able to build a tall building. That is the very first thing that they have to plan, is how to build a strong foundation. There's different ways to make foundations, but as you are planning and building your towers, you're going to notice that different types of shapes and different ways to build foundations is going to affect how tall you can make your tower. But in order to build a building that is tall and strong, you have to make sure the foundation or the base is solid and stable. So as you are planning and designing your towers over the next 4 days, I want you to really be paying attention to your base or your foundation. Now, back to our engineering design process. As you build your towers, I want you to be thinking about the engineering design process that we learned in the video. We're going to kind of condense some of the steps that Sabrina shared in the engineering process, and we're going to follow these 5 steps in our engineering design process. So the first thing we always do is ask, what is the problem? We already identified that we want to build a tall tower using materials we have in our home. The next step is to imagine. This is where you're going to brainstorm possible solutions to the problem. Think about your material. How are you going to use that to build your tower? Then you're going to plan. This is where you draw a picture of your idea. What is it going to look like? Gather your materials, because the next step is creating. This is where you actually go ahead and build the model that you planned. The last step is improve. As she talked about in the movie, in the video, engineers, a lot of times they fail the first, second, even the third time. Do they give up? Hopefully not, because if you give up, you're never going to come up with the best solution to the problem. Even when they think they have a solution that works, a lot of times they still go back and reflect and find ways to make it even better. That's what engineers do. They problem solve and they reflect and they look for ways to improve things that other people have already designed. After you create your tower, I want you to think about that. What worked? What didn't? Did it fall over too easy? Was it too hard to get it stand? What could have made it better? What would have worked better than what you did the first time, or maybe even the second time? So what can you use to build your towers? Look for things around your house. These are just some ideas of things that you might be able to find around your house that you could use. Straws and tape, blocks, playing cards, index cards, pencils, craft sticks, cups, dominoes, paper, noodles and Play-Doh, plastic bowls and containers, DVD and CD cases. If you have the game Jenga, those planks work great. Toilet paper rolls and cardboard, paper plates and cardboard, pillows, plastic cups, empty boxes. There's lots of different things. You just have to be creative and see what you can find. I just wanted to give you some ideas of things that you could look around your house for to find to build your towers. I looked at that list of supplies that I had, and I wasn't able to find everything on the list, but I was able to find at least 4 items that I know I could use to build a tower. I was actually surprised when I started going around my house and I started to find things that would work to build a tower. So I found lots of decks of playing cards, and I picked these because I thought they were kind of cool because they're super big. I thought that might be fun to build a tower out of. I found lots of CD cases and DVD cases, different sizes that could be fun to build a tower. I found a package of plastic cups, so that's going to be one of my days. I'm going to make a tower out of plastic cups. I found lots of different sizes and shapes of plastic containers with lids, so I think one day I might try to build some type of tower out of plastic containers. I couldn't find craft sticks, I was looking, but I did find some boxes of just pencils that I can use if I'm creative to try to make a tower. I found some Play-Doh, and I know one of the suggestions was using like Play-Doh with some noodles, so I'm gonna maybe try to build a tower out of Play-Doh and noodles. And I found some marshmallows. I think I might have some toothpicks downstairs. I think that's an idea is using some marshmallows with toothpicks. So there's lots of different things you can find around your house. You may have to do a little bit of digging, so I'm sorry. I was hoping that you wouldn't have to, but you'll be surprised at the different kinds of things you can find in your house. So have fun and happy searching. Your assignment for today is to start looking around your house and gathering your materials. What items do you have in your home that you could use to build 4 different types of towers? I showed you things that I found around my house. See what you can find around your house and have your first material ready for tomorrow, because we are going to start building our first tower and doing our first STEM challenge tomorrow. I'll see you back here tomorrow morning. Bye, everybody.